Good afternoon. I'm Dr. Ivelina Kadiri from the University of Economics in Varna, Bulgaria. Today, I'm presenting research on genomic personas as human technosignatures in Earth space governance, exploring how humanity's genetic data architectures reveal planetary intelligence through systematic organization of biological information. The space economy reached $613 billion in 2024, projected to reach $1.8 trillion by 2035. Precision medicine frameworks now guide astronaut selection through genetic markers for radiation resilience and cognitive stability. This represents a fundamental shift from individual health data to planetary-scale information architecture. My PhD research develops the Astronaut Genetic Persona Mapping framework. It integrates genetic markers capturing variations in radiation response, neuroplasticity, and circadian regulation. Behavioral profiles map variants to cognitive patterns and team dynamics. Through NASA's SOMA Atlas and GeneLab databases, this transforms individual genomic data into planetary-scale information architecture. Traditional technosignatures include narrowband radio transmissions, megastructure silhouettes like Dyson spheres, atmospheric industrial pollutants, and artificial lighting patterns. I propose a new class, informational technosignatures. These include complex database architectures, algorithmic translation layers, non-random curation patterns, and self-reflexive encoding. Genomic databases represent detectable signals, informational architectures encoding biological intelligence through deliberate design and planetary coordination. These genomic persona systems meet 4 technosignature criteria: complexity, multi-omic integration operating beyond natural selection timescales; non-randomness, curated datasets optimized for specific mission outcomes rather than natural variation; design inference, deliberate database architecture reflecting societal priorities and engineering constraints; self-reflexivity, intelligence encoding systematic information about its own biological constitutive mechanisms. This creates governance implications. National frameworks regulate genetic data on Earth with clear boundaries, but no framework addresses genetic data in orbital or deep space contexts, creating jurisdictional ambiguity. Genomic data governance becomes a subfield of astropolitics. How do we detect these informational technosignatures? We analyze existing databases, map complexity using network metrics, and compare patterns across scales. Future directions include quantitative modeling and ethical frameworks for genetic technosignatures. This represents a paradigm shift. Traditional views search for distant radio signals or megastructures. The expanded view recognizes Earth's own informational technosignatures, genomic databases reflecting planetary intelligence. This transforms technosignature search from astronomical observation to sociotechnical inquiry. Beyond informational architectures, human DNA emits ultra-weak biophotons during replication and stress. First documented by Pop in the 70s, these quantum emissions represent a physical substrate beneath genetic data systems. Could biophotonic signatures constitute a detectable biophysical layer? This opens new directions for future research. Genomic personas function as both biomedical instruments and symbolic artifacts, revealing how Earth-bound intelligence systematically encodes its evolutionary narrative. Beyond databases, biophotonic emissions from DNA suggest a biophysical technosignature layer worthy of investigation. This research bridges astrobiology, quantum biology, data governance, and space law, proposing that humanity's genetic data systems constitute detectable signatures of planetary intelligence. I'm seeking collaborations across SETI institutions, space biology labs, quantum biophysics, and bioethics communities. Thank you.